All right, so I just want to start with a land acknowledgement. So Nature Nova Scotia and Ecology Action Centre are gathered today on the ancestral and unceded territory of the Mi'kmaq people. This land, known as Mi'kma'ki, has been the site of human presence and activity for thousands of years. We pay our respects to the Mi'kmaq elders, past, present, and emerging, who have stewarded this land, waters, and resources throughout generations. So with that, I just want to welcome everyone to day 2 of Wetlands Appreciation Week 2023. It will be taking place from August 14th to the 19th, and Wetlands Appreciation Week is unique to Nova Scotia. It's also a collaborative effort from many different groups, but today's webinar is hosted by Ecology Action Centre and Nature Nova Scotia. I'm also going to post the link in the chat later for the list of events that's happening, because there's a lot of guided hikes, webinars, and other interactive activities. We're really excited to have everyone here. I'm Jess Lewis. I'm the Conservation Coordinator with Nature Nova Scotia, and I'm co-hosting the webinar with Mimi O'Hanley, the Wetlands and Water Coordinator at Ecology Action Centre. We also have Dr. Danica Van Prusage and David Patrickin to talk about the significance of wetlands in the face of climate change. Lastly, I just want to ask that everybody please save your questions until the end, and then we have about a 20-minute question period put aside, so you can either put your questions in the chat or raise your hand. Also, please keep yourself muted, just out of respect for the presenters. So with that, I'm going to start with Dr. Danica Van Prusage's introduction. So she is a coastal geomorphologist and professor in the Department of Geography and Environmental Studies at St. Mary's University. She works to understand how the biophysical processes of coastal ecosystems respond to natural and anthropogenic drivers of change. She has fostered a long-term partnership with CBWES over the last 18 years, applying innovative and proven techniques to restore over 330 hectares of tidal wetland habitat. Together, they established the Transcoastal Adaptation Center for Nature-Based Solutions in 2019, which she is the director. So with that, Danica, if you want to go ahead and share your screen.
Great, thank you very much, Jess, for that.
Welcome.
Great, so thank you. So as Jessie was introduced earlier on, I am Dr. Danica Van Pruste, and the work that I'm going to be presenting today and the work that we do is not in isolation just at St. Mary's, and reflects long-term collaboration with CB Wetlands environmental specialists, the province of Nova Scotia, as well as Dalhousie University. So I'm going to be focusing on making room for wetlands and how by doing so we can actually, this is a demonstration of the application of nature-based climate change, and that we can actually make our coastal communities more resilient. So for those of you that aren't familiar with TCA, we are a center of expertise that's situated at St. Mary's University, and our mission is really to help build climate resilient communities and ecosystems by protecting, enhancing, and actually restoring natural processes through innovative research, collaboration, and the implementation. And we operate under 3 primary pillars. One is research and innovation, where we push the boundaries using the latest science to have better outcomes for our restoration activities. Education and outreach, which is similar to events we're doing today, where we work with communities, NGO groups, consulting firms as well, and educational institutions to train and provide support and guidance for implementing nature-based solutions. And then finally, application, where we're actually working on the ground to apply nature-based solutions within Atlantic Canada primarily. I think we're focusing very much on tidal wetlands, and tidal wetlands provide a whole bunch of co-benefits. So these are benefits that arise because of all the different functions and important things that a tidal wetland does. And so that can range from some of the more climate adaptation processes or protective functions, like stormwater retention and filtration, erosion protection, like a wave energy dissipation, but it also can provide other environmental services like providing migratory corridors for fish, habitat and areas for nurseries for fish itself, as well as the natural process of erosion and sedimentation can actually create additional land and additional habitat. We also have a lot of the cultural values associated with tidal wetlands. I'm not going to talk about it today, but a lot of the work that colleagues at Dalhousie University in particular are really honing in on what is being done within that landscape. Now, coastal wetlands have been increasingly recognized as providing risk reduction resilient benefits. And the approach of working with nature rather than against it has been gaining a lot of support and momentum, both at Canada level, whether it's the Insurance Bureau of Canada in 2018, or internationally with the Engineering with Nature guidance documents that came out just over last year. And this is where more using a nature-based climate adaptation lens allows us to leverage the natural processes of our tidal wetlands to provide all these ecosystem benefits and protect our coastal communities. The work that we're conducting takes place in the Bay of Fundy. This is a hypertidal estuary, so highest tides in the world between the provinces of New Brunswick and Nova Scotia. And it also incorporates some of the most vulnerable areas within the Atlantic region. So the area in red is what you see in the satellite image on the left-hand side. And this is where we have the Chignecto Isthmus, which is a narrow strip of land which basically links New Brunswick and Nova Scotia, and that has a vulnerable transportation corridor with the Trans-Canada Highway, that if there were a breach in that area, that we would have about $50 million of trade a day being disruptive. A lot of the areas that were historically diked by Acadian settlers, the Acadians diked former tidal wetlands and removed those from regular tidal inputs of sediment, which I'm going to talk about in just a moment about why that's important. Over time, it created very fertile agricultural lands, and over time, that land subsided in relation to the land in front of it. And this causes increased vulnerability for our dikeland communities. The province of Nova Scotia in particular has 364 kilometers of dikes and associated infrastructure, protecting about 32,000 hectares of low-lying land behind them. And some communities, such as the town of Truro, for example, experience regular flooding as a result of heavy freshwater drainage during storm events, frozen ground, ice jamming, and a number of other variables. And a comprehensive flood study by led by CBCL Coastal Engineers, or Engineering Limited, identified that managed realignment is as one potential option. So opening up the floodplain as one way of trying to mitigate some of those negative effects. And I'll use as a case example a little bit later the North River Onslow Managed Realignment and Tidal Wetland Restoration Project, the outline that you see in blue on the right-hand side. In addition, the province was able to receive funding to apply and help to increase the resilience of areas of dikeland within the province. And so we've been working with them collaboratively to look at the 7 different options that exist for helping to make the dikelands more resilient. Now, we've had globally that marshes are, as I mentioned earlier, they're being recognized as natural forms of coastal protection. And in the context of what I'll be talking about in terms of making room for wetland, where we're providing that space for wetlands to grow, is the importance of the foreshore marsh. So this is a marsh that exists in front of a dike. And this is an example, a schematic of when we have a foreshore marsh in place, it actually provides a protective function for the dike behind. Areas that don't have a foreshore marsh end up having higher waves that reach the dike, more overtopping, and more risk of breaching or the breaking of the actual dikes. And the foreshore marsh provides a number of important benefits, particularly for protection. These are the attenuations of waves, making waves smaller, stabilizing sediments themselves through the root mats, as well as accreting sediment, allowing for the accumulation to take place. In addition, this international acceptance of building with nature also adds a mitigation benefit of sequestering carbon from the atmosphere and storing it within the sediments and root biomass. Now, the concept of making room for wetlands is based on the premise if one provides the optimal conditions and the geographical space for reestablishment and growth of tidal wetlands, then these restored systems can provide those ecosystem services and protection function. So in managed dike realignment, a new dike is built on the inner area to protect critical infrastructure or agriculture that needs to be protected. And it's increasingly being implemented as one option to increase the resilience of our dikelands in the province. In that process, a hole is cut within that dike in a strategic location, water control structures are removed, and tidal waters are allowed to come in. These tidal waters contain abundant sediment and nutrients, and over time allow for the establishment of a tidal wetland. In addition, so that brings them the co-benefits of the foreshore that we talked about earlier. And this is a process where we have a lot of documentation on our TCA site if you're interested in learning more, particularly about the North Onslow project. And what you're looking at is the figure on the left-hand side. This is the reintroduction of tidal floodwaters just outside of Truro. And on the right-hand side, this is the beginning evolution of a tidal wetland landscape. So as those tides come in, they deposit sediments. And now if you go to that site, we have creeks that are forming, we have new vegetation that's establishing as well. And what we're doing is we're enhancing the resilience by leveraging natural processes. So if you look on the figure on the bottom left, every time a tide comes in, particularly in the Bay of Fundy, it brings in sediments. This is then trapped by vegetation, and over time, this allows for the surface to rise up with rising sea levels. The plants also, if they're happy, they have strong roots and biomass that add to that elevational increase. So this means that they're dynamic and they're able to adjust their elevation based on sea level rise, which is something a rock wall can't do. So most of our work, we look to leverage the natural processes and the capacity of these marshes to self-engineer. In some cases, we do planting of plants, but in many cases, as we see on sort of the sequence diagram in the top area, that if we restore the tides properly and give proper kind of flushing and inputs of material, we actually have natural reestablishment of vegetation very, very quickly in the upper part of at our Walton River site within 15 months. And we also use the capacity to self-engineer to allow the channels to evolve on their own. Now, our work has evolved over the last 18 years, and we have been working very collaboratively with CBWS as well as the province of Nova Scotia, and have restored about 400 hectares within the province. And all of these sites undergo a pre- and post-restoration monitoring so that we can really, one, understand what's happening, but also so we can we can learn from those experiences, and we can also provide more confidence to areas that are wanting to undergo future about what this may look like. And these become living laboratories for research as well. Now, through the reintroduction of this tidal flow, it really is about reimagining these transforming landscapes. And this allows us to look at how we view our coastal zone from one that is static to one that is dynamic, and public amenity to the private, for public to the private good. So this is in Jijjiwuktuk, this is near Kentville. This is our St. Croix, our Belcher Street restoration site. And on the left-hand side, you can see an agricultural field with an area here that is underutilized. It's also fallow, and eroding dike at a number of locations. A new dike was constructed landward, which provide better access for the farmer to use the remaining land and provided increased protection. Over time, within a 2-year period, the marsh had reestablished itself in almost fully vegetated within 2 years, and we now have the restored tidal landscape. So this is now transformed, and locals that walk this area remark on butterflies that they hadn't seen previously in that particular location. But it transformed the landscape from one view to another, and that's part of what we really need to be looking at within these systems. In 2017, we were fortunate to have been awarded funding from the Department of Fisheries and Oceans for the Coastal Restoration Fund for our initial Making Room for Wetlands project. And through this and building upon the experience that we had in previous projects was to implement management alignment and tidal wetland restoration, but also develop a framework and the stages to help guide us kind of moving forward. And this was established using initially engagement, gathering baseline data, designing, implementing, and monitoring. And all of this is an iterative process, and each project feeds into another to help us learn and understand our restoration landscape. In addition, and we'll talk more about the future projects that are associated with that. So, as I mentioned with Living Laboratories, we have been able to bring together and leverage a variety of different funding sources and multidisciplinary research teams, from coastal engineers to social scientists from within our collaborators. And this has allowed us to build a knowledge base that allows us to better understand these transforming landscapes, and particularly the ResNet funded by NSERC, as well as a project for coastal resilience and risk reduction with the Natural Research Council. But I'm going to focus right now in terms of 3 examples of how tidal wetlands can be used for climate change adaptation. 1, for erosion reduction, stormwater regulation, and then carbon sequestration. So in the first, the plants themselves provide an incredible opportunity to decrease wave action. And we have been able to do field work in the field. This is Maka doing her honors project, where we were able to physically measure in a transect that you can see here how much the wave height decreased as we moved from an unvegetated mudflat further down into the vegetation canopy. And what her work was able to discover is that in periods of time when the water depth was completely within, so the vegetation occupied most of the water column and the water depth less than 1 meter, within 10 meters of vegetated surface, we had an 80% measured decrease in wave height. That's a lot. In areas where we have deeper water and the canopy occupies half of that amount, we only have about a 3% decrease and about 62% at about 50 meters. We were able to further expand this and look within the Thick-Neck Isthmus about how does that actually translate into potential dike design. Because
Danica, yeah, just to let you know, you're at 15 minutes.
Okay, thank you. So we know that the effectiveness of foreshore marsh depends on a variety of what the actual foreshore looks like and the actual condition of the foreshore itself. So whether it is growing, eroding, or newly forming. And if we can integrate this into dike design, it means that we can integrate the actual amount of vegetated foreshore we have in front of a dike to perhaps lower the height and the cost for our dikes themselves. If we think about overland flood management, this is the area where 90 hectares are restored within the area of Truro. The modeling suggests that we already do have decrease in flooding. So this would be an area around that was decreased in terms of flooding based on the preliminary models. And we're currently now looking at how it is affecting flood levels in the present day after the implementation of the realignment. Now, this opening up of the floodplain is particularly important for reducing flood levels and flood risk, particularly in areas that are further up, so they're closer to the freshwater influence, and where we have higher sedimentation, so that the very sediment-laden tides that come in don't deposit in the channels, but deposit on the flats, and that also decreases dredging components. Now, these rich sediments allow us to have carbon that's brought into the system. And tidal wetlands sequester organic carbon through two primary mechanisms. One, through the plants themselves, where they take CO2 from the atmosphere and they transform that primarily into carbon in their tissues and their roots. And then some of it is stored within the soil. And the other is allochthonous, coming in externally in those high sedimentations and accumulates within the site. And trying to understand the relative contribution of these different components is important for us to look at carbon storage and burial. And I don't have time to go into detail with it, but previous studies have shown that these very high concentrations in the upper bay in particular have the potential to store a significant amount of carbon within the system. But we also need to consider the inputs and outputs of the carbon itself. Two sites where I'm going to focus the last remaining time that I have is on the Belcher Street site that I've talked about earlier and introduced you to in Jujewuktuk, as well as the Converse March, where we're actually having a field trip tomorrow if anyone is interested. In both cases, these are situated in different parts of the estuary, but tidal flow was restored in the same time period in 2018. In the two different cases, this is for the impact of sedimentation in the Belcher Street site. We had very rapid sedimentation, so about 35 centimeters of sediment came by year 3, 18 centimeters in the first year. So it kind of filled up with sediment. And what that allowed to happen is it buried the agricultural surfaces and allowed for vegetation to establish quite quickly, as well as providing a very high amount of carbon accumulation. But the rate of how some of this vegetation established really differed between the two sites. So this is an example. This is a time series that looks at how vegetation has evolved at the Converse site. And you can see that even 2 years post-restoration compared to Belcher, we still had a lot of bare sediment. And it's only now by year 4 that we start to see the persistent establishment of that vegetation. And so what are some of the considerations that we need to think about for implementing these approaches and using tidal wetlands for nature-based as a nature-based solution? We have to consider not all marshes are considered equally, and we have to consider the position within the estuary, and that the engineering design itself can also impact the overall evolution itself. The timing of the earthworks to allow for the establishment of annuals to protect that fragile inner dike in the initial, and to provide a substrate to allow for more sedimentation, and to plan for adaptive management, which means that we have to plan for things that may not go according to plan and to implement those. And so in terms of future directions, our Making Room for Wetlands projects are continuing with additional funding from the federal government, with 2 projects, our Coastal Carbon Edition and the St. Croix Edition. But a big thing is that the dikeland space is complicated, and working in these environments requires us to speak with multiple different stakeholders. Our current projects are now looking at integrating and working with CMM and integrating more of a two-eyed seeing into the approach that we're using. But in all cases, that early engagement with stakeholder rights holders is really, really important. And just all of this work that we have been conducting within TCA and with all of our partners, it is a result of lots of different people, students, as well as funding bodies. And thank you very much.
Thank you so much, Danica. That was a great presentation. So with that, I'm going to move into David's presentation. Just going to give a quick bio. So David Patrickin retired as a professor of biology at Dalhousie University in 2008. Since then, he has been active in several trail and natural history organizations and has conducted plant community surveys that contributed to protection of the Five Bridges Lake Wilderness Area, the Williams Lake Backlands, now the Shaw Wilderness Park, and 2 nature trust properties on the Chebucto Peninsula. He has ongoing studies of Sandy Lake in Bedford, the backlands, and a French village conservation woodlot. All right, thank you, David. You can go ahead.
Okay, thank you. Everybody hear me okay?
Yes.
My studies are much more informal than Danica's, more the nature of a retired professor, perhaps. Danica's obviously still very active. What I'm going to talk about, I like to spend as much time as I can, as close to home as I can. And one of the areas I've spent a lot of time exploring are the backlands. And in 2013, I did a detailed study, volunteered to do a detailed study of the plant communities, and involved Nick Hill, specifically because he's really the Nova Scotia expert in wetlands, and as well as a close friend and colleague of mine. And a lot of what I'm going to talk about is comes from his work. It's described in detail in our report. And also, another person has been quite involved in looking at wetlands back there is Patricia Manuel, who I'll talk about. So I'm going to just spend most of my time describing some often overlooked components of the wetlands and watercourses, and just a little bit about climatic factors. So to begin with, where are the backlands? Well, probably many people looking at this webinar are familiar. They're just off Peninsular Halifax and comprise the area enclosed by Purcell's Cove and Herring Cove Road, and by Williams Lake at the northwest, and Powers Pond at the southeast. And it's a large, essentially undeveloped wilderness area with 9 lakes, lots of trails, and so on and so forth. And there's people now are very actively trying to conserve as much as that is possible. And one of the things we identified in our 2013 study is it hosts a globally rare fire-dependent plant community, the Jack Pine Broom Crowberry Barrens. Approximately, these numbers are not accurate at all, but approximately now 60% of the land is either crown or is formally protected. So some big sections, all the colored stuff, including Clayton Developments, now the Shaw Park, is protected, but you can see there's still a lot of fragmentation with the private land that remains. It includes 2 major watersheds, the McIntosh Run watershed, a large component of which is outside of the backlands and begins up around Bears Lake in that area, so includes quite a lot of dirty water. And then there's the Williams Lake watershed, which is about 3/4 in the backlands, but also includes an urban component. And then there's some smaller watersheds over here and down by Herring Cove. And I like to think about the wetlands in the context of watersheds and watercourses rather than as isolated wetlands. Geologically, if you look at this at the superficial geology, most of it's described as bedrock, which is either bedrock or very shallow soils over most of the area. It includes a very significant, if you look at the subsurface geology, it includes a very significant contact zone between the granites, which are about 350 million years old, and then the Maguma rocks up here are just southeast of Williams Lake. There's a big significant contact zone. I'll talk quite a bit about that zone. And then if we look at the vegetation, all of this this stuff here is all the what I describe as blueberries or barren, so not much forest. So a lot of it's covered with forest. Tends to be quite young forest because the area is burned quite regularly. It includes hardwoods and softwoods. Now we look at the wetlands. This is what's officially mapped. And it adds up to 87.2 hectares, or approximately 6.5% of the backlands, which is close to the average for the province, which is using the same criteria as roughly 6.6, as I understand it, in freshwater wetlands. So that's kind of what we accept as the wetlands of the backlands. But a lot of what I'm going to talk about is what's not included in this slide. A very significant figure here, there's very few bogs. And there's also very few surface waters in this larger area. Here's where you see surface, open streams. But this whole area, you see very few perennial streams. You may see seasonal streams. And bogs, well, 3/4 of the wetlands in terrestrial Nova Scotia are bogs in Nova Scotia. They're only about less than 5% in the backlands. And a really good, nice example is this bog on the top of Piggy Mountain. And, bogs are really the only self-contained kind of wetland. All other kinds of wetlands are in watercourses. And that's a feature that we tend to overlook in a lot of our wetland conservation and concerns and so on. So here's kind of a diagram of an overview of the water flow in the wetlands. And a lot of the water that hits the wetlands falls on the rocklands, in the ridges, the barrens, and the whalebacks. And it doesn't hold it, it just flows off right away. And this pathway is the pathway that Nick and I mapped for the movement of that water. And it can then go into what we call boulder fields or mountain holly washes, then go to vernal pools, then into fens and swamps. And some of those fens and swamps can feed back into those same kinds of systems. And then eventually it gets to the lake. Now, another similar components to that are what I call the fields of whalebacks. And I'll talk a bit about those. They got similar characteristics, but they're a little bit different. And the significance of these small wetlands, particularly, and I should say the ones with the asterisk, are generally not recognized or protected. And the significance of the wetlands in this system are that they slow, besides being important for biodiversity, in terms of water movement and so on, they slow, cool, and filter the water. Okay, so here I've just added a few diagrams to show you what these systems are like. So we're showing the ridges up here, these boulder fields, which are large pieces of angular rock that were dropped by the glaciers. When I first saw them, I thought they must have been old quarries, but they're not. And you see that over quite a bit of the Chebucto Peninsula and possibly other areas of Nova Scotia. These are examples of the mountain holly washes, and these are really wonderful areas with this magnificent plant, mountain holly. And once you recognize it, you'll see a lot of them on the Chebucto Peninsula. And then here's a vernal pond up here. So this pond will be completely dry in summer, except maybe this summer. Fills up every now and then. And is not generally recognized, although it will qualify as a wetland formally. It's often just completely overlooked in wetland delineation and so on. And then down here we have these boulder fields. This is up around Governor's Brook. These are really amazing. I think these are almost globally rare. The way we have them in the backlands is it's close to a globally rare landscape, I believe. We really need to look into that. And then as we get lower down, we have significant floodplains, these large wetlands and so on, and then we get into the lake. So I'll go over each of these a little bit. Now here's a diagram that Nick put together, how he traced the movement of the water through these different components in the watershed. And I should say that these landscapes are really, I think I've got it to the next one. Oh, possibly not. Yeah, another significant aspect here in the Williams Lake backlands is that a lot of the larger wetlands lie along this contact zone. And you can see how you've got these outcrops and ridges on both sides here. And then this is this contact zone between the granitic rocks up here and the older Maguma rocks here. And this whole area is a contact zone, and there's large wetlands all along here. And that water tends to flow along here. So a lot of these other components are here that feed into these large wetlands. So this is a very significant component of this whole thing. And a point to emphasize is that the backlands are very much a mosaic of habitats. You can tell that just looking at Google Earth. So you can have a wetland right next to a dry land. You can have forested area right next to almost a desert area, and so on and so forth. It's just an important component to recognize when we're looking at these issues. So to go through, to give you some visual examples of some of the components of the systems, the ridges, and if you've been in the backlands, you know what I'm talking about. You're talking about the outcrops. Here are the whalebacks down here. So this is where, the water that falls here, it just flows down very, very quickly. where there's trees and so on, you get a lot of interception and that will slow it down. But a lot of the water that comes in flows in here very quickly and then goes into the, boulder fields and the washes and so on. So here's an example of the boulder fields. They're quite spectacular when you see them. They rarely have standing water, but you can usually hear water below them. They do not qualify as wetlands or even watercourses, but they're definitely watercourses. There's very little living in them, possibly because of toxic materials in the rocks themselves. And then here are some pictures of the mountain holly washes. I don't know if Sheila Stevenson is here, but I've included one behind her house. And, you have these lovely gnarled mountain holly plants that form these washes. And I'll leave you to read a bit about this in the posted slides. I won't spend a lot of time going over it, but these are legally wetlands, except for one problem, that the mountain holly in Nova Scotia is classified as a facultative wetland species. In the US, it's classified as an obligate wetland species. So the vegetation doesn't meet some of the criteria to qualify for wetland in the Nova Scotia system, but the soils themselves generally do meet those criteria. It just gives you an example of the problem of protecting these areas when they're a little different. And these washes I've discovered since that study can occur on some very extreme slopes, and they're really quite spectacular. Some examples of the vernal pools. This is in the springtime when they're full, and these you get on the landscape. You get kind of little. You get these kind of. Let me see what Nick how he describes it. It occurs wherever there are depressions in the landscape and there are impermeable soil or rock layers, size less than 5 square meters to hundreds of square meters. And they're kind of like where you get areas where the water levels out and it doesn't go into the ground, you get these areas. And then they'll dry out. And in the summertime, they just look like an open leafy area. And generally the water movement between them is mostly underground. And often you'll find a little spring above them, as shown at the bottom left, going into it. And a lot of the water movement in this landscape is seasonal, and a lot of it is below ground. So we tend not to recognize it. This is a map by a student, Patricia Manuel, based on LiDAR and other types of imagery, showing all potential vernal pools. So you can see there's a heck of a lot of them in this landscape. So very significant, but not recognized wetland. And also part of these watercourses. Now, the whalebacks and troughs, I said, to me, these are very special, almost unique systems. If you've been on the bike barrens back by Governor's Book, you've been through them. And so you have the whalebacks, which look like whalebacks, and then you have the depressions, or I call them troughs because they're like waves and troughs. And those troughs are areas of water movement. And where they're wetter, you get typical wetland vegetation as shown at the right. And these are quite small systems. So again, they're not recognized as wetlands or even watercourses, but they are both. And very important features of the backlands. And then some examples of the larger wetlands we can't really overlook because they're large, they're prominent, they're beautiful. And depending on the season, they're very, very, they're full of water. So the classical type of wetlands, which generally are protected. Okay, I'll talk a little bit about some of these climate influences. Fire and wetlands in the backlands. I mean, basically, on the map at the top left shows you roughly the limits of the 2009 Spryfield fire. And the X's are areas where I've looked at, quite familiar with, are larger wetlands with to stop the fire. You can actually see the boundary between them. So the fire stopped at those, and the fire moved more or less westward, or from eastward, from southwest to northeast. It moved across the landscape from left to right. And these larger wetlands stopped the fire. It was a factor in the fires stopping in those areas. And I've shown some of the interfaces here on the right. some of these wetlands are not recognized. For example, this bottom one here, this is in this area up here, and it's not recognized at all as a wetland. It's a forested wetland, and here's some tamarack in it. It may not formally qualify as a wetland. I really don't know. It's not recognized on the maps. You'd have to go out and do it, but it certainly acted like a wetland, and it certainly stopped that fire moving up here. It's very clear even today.
Hi, David. Just to let
Yes.
you know that you're at 15 minutes.
Okay. Now the smaller wetlands are essentially burnt, and I should say the whole backlands is an area. It's one of the most fire-prone areas in Nova Scotia, and the vegetation, except around the permanent streams, is highly adapted to fire. So the smaller wetlands burn over. Everything gets burned, but they recover within 2 to 3 years. That's been my observation of them. So all of these smaller wetlands burn, but this summer they were really full, and the water is still flowing out of those wetlands. So it's still holding the water back from, it's still holding those heavy rains. So these big wetlands is where that water is stored. I've done a little bit of studying of invasive plants in the wetlands. And this summer I was a bit concerned about finding a lot of Rosa multiflora up here on the top of Lawson's Brook. So I did a survey of the wetland plants and found quite a bit of multiflora rose and Japanese knotweed, and also border privet hanging over the wetland. So these would be interfering with the wetland. The multiflora rose definitely competes with Canada holly. I'm not sure what Japanese knotweed competes with. It tends to spread over the stream. Border privet probably competes with Canada holly. Another one I found, which is not really aquatic, but on the borders, was Japanese barberry, not even recognized as an invasive species. But interesting, if you go on the single track trail, now that's an area that has quite a history of industrial use. There's a lot of activity around and so on. But the trail going from here right all along through these wetlands, right up to these wetlands, I surveyed this hole very carefully. And it's a fairly well-walked area, and there's not one single exotic or invasive species. So it's evidence that that's really an ecologically intact system, which is very encouraging. I've also done studies on the limnology of Williams Lake, a little bit on Culpet Lake, and Charles Bull had volunteered to do some electrical conductivity monitoring Governor's Brook up here, and so we have a little bit of idea how the waterways that have urban influence are affected by salt loading, and also that would mean other pollutants. And this just gives you some approximate average values. So these are background values off of undeveloped land, very low electrical conductivity values. That's basically pure water in terms of natural systems. Here we have very heavy loading from up around Bayers Lake. It goes into Culpet Lake, gets diluted as it comes down here because there's water going in here into Williams Lake. Again, very low conductivity water coming in here. So this would be high conductivity water going here. And these levels, if they get much higher, they're getting into the area where they're potentially toxic, long-term chronic toxicity to aquatic life. And the main factor affecting the salt levels in these types of systems is the percent developed on the landscape. And right now, that's not moving. Williams Lake watershed is fairly stable. The Culpet Lake watershed is probably fairly stable. It probably won't increase a lot more, but where we do increase them, we get increased salt loading, and that's becoming a bigger issue. I just mentioned that. So I'll close with what's protected, and that's kind of a lot of the point of the presentation, that most of what I've been talking about is not protected. We don't protect small wetlands. We know that. Here's, to me, a terrible example of one that was taken out up on the top of Ocean View Drive, a beautiful little wetland, right on the border of 100 square meters. And it was simply taken out and a road put in. But these other types, they're often not protected because they're either not recognized as wetlands or they're too small. And yet they account, I think these unrecognized wetlands would probably triple the amount of wetland and water course in the backlands compared to what we kind of formally recognize. And Nick Hill describes this area as having features of dryland systems in which as much as 80% of the water flow is below ground and through these types of unprotected systems. So those are some of the special qualities of the backlands, and that are important both for, it's one of the reasons we make the argument that we really don't want to develop the backlands, because you simply can't substitute for these types of systems. They're almost very unique types of systems. Anyway, I think that's it. I'll stop. Thank you.
Thank you, David. That was great.
Okay. Totally forgot to record it, but anyway.
Oh, I recorded it.
Okay.
Yeah, so I can send that to you.
Okay, thank you.
With that, I'm going to open the floor to any questions. And like I said earlier, you can put your questions in the chat, or you can also raise your hand if you prefer like speaking directly. Yeah, I mean, I kind of have a question about the vernal pools, which is kind of like something I've been interested in. Why aren't they like considered wetlands, or like why aren't they, like when people are doing up maps, they don't often include them?
Well, because part of it would depend on when they map, and if you're not mapping in the period when there's high water, they're easily overlooked. And a lot of the wetland delineation, Nick is the guy to talk about this, but wetland delineation tends to be about defining a big wetland and putting boundaries on it. And so people just tend not to look at water courses and these more subtle things. And they tend to get lost in that mix. And of course, the smaller ones, a lot of them are smaller than 100 square meters. So even if they recognize them as wetlands, they're not, there's no obligation to protect them. And probably majority of the ones in the backlands are less than 100 square meters, but collectively they're extremely important.
Yeah, I agree that they're important. I mean, I have one close to my house that is often fluctuating, but I see like all sorts of different critters in there.
Yeah.
I'm also curious if either you or Danica have been to any of the like fire sites. I was recently out in Shelburne and drove past this sort of like bog that had completely been burnt, and I'm just interested about like the regeneration of that, and if either of you know anything about it. Or
well, I followed the after the Spryfield fire. I was out there within 4 days. In fact, the DNR helicopter came in and told me to get out because the ground was still smoldering. So I followed that for 16 months. And I actually have a set of slides on that on the Halifax Field Naturalist website. And, the backland systems recovered quickly because they're all essentially fire adapted. And I think a lot of what burnt in Nova Scotia will recover fairly quickly. The stuff, but that fire burned deeper than a lot of the spring fires, and a lot of may not recover that quickly. I think a person to talk to about that would be Donna Crossland, because she followed that quite bad fire. I think it was 2017 or 18. There was a bad fire in the late summer that burned fairly deeply, but I think even that system's coming back. So they do tend to come back. Yeah, that's all I can really say about it. I haven't actually looked at some of these recent burns. I'd like to do that, but it's surprising how quickly they come back.
it is, yeah. It's like all blueberries returning. So next year there'll be
very good for blueberries. Second year after the fire. Very good.
Yeah.
We also have a couple of questions in the chat, but Danica, I don't know if you had a response to Jess's question as well. No. So one question we have is what steps can be taken to protect the remaining small wetlands? Very insightful presentations.
Sorry, who are you asking that?
Oh, I think it could be to both of you, but I think David, you talked about the small wetlands specifically. So yeah, any steps that can be taken to protect them.
You know, my honestly, my kind of perspective on this at this point, you know, you take these recent floods and what they did, we now know why we need these systems. You know, and our wetland protection, our watercourse protection that we have to date, it has not been adequately protecting those systems when we get these types of floods. So again, you know, this is my own perspective. So that really what we need to do, and that we're recognizing more and more what we need to do, is we need to concentrate our development in areas that are already developed, you know, densifying. And in my mind, we should never develop in an ecologically intact area when there's an already degraded area available. Now that's a hard pill for a lot of developers to swallow. But I know areas, there's one area 12 out by Sandy Lake right now, that's up for development. And it's covered with trees, it's got significant wetlands. They had horrendous floods there, you know, with that recent floods back there. And if they do the normal type of development there, and also west of Sandy Lake, it's going to be a lot worse in future. So to me, you know, you just can't, like in the back, you cannot protect. How are you going to protect so many of those small wetlands without protecting the much larger area? So to me, you know, I appreciate your thing about how to protect these small wetlands, but it's kind of a collective thing, and that we really, I don't know how Danica feels about that, but these recent floods, man, they really showed us that these things are really. And one thing, I went up in the Williams Lake backlands after those floods because I wanted to see in the intact system if it made a mess of the forest. It did not. It absolutely made no mess of it at all. You know, a bit of mud thrown around and stuff, but no damage there at all in the intact system. So that's kind of, I think, to me, those are the kind of levels we need to start to think about those things.
And I think, David, you raise an excellent point, and I really loved in your presentation how you looked at the impact and the importance of these wetlands on tidal flow and flood regulation, because I think that's something that we're missing right now within our both land use planning and emergency management. Is we have sort of the environmental specter looking for protection for a habitat ecosystem perspective, and that we have EMO simply looking at perhaps topography, low-lying areas, and water courses, but there has been no work to integrate the two and looking at the benefit. And this perhaps is an opportunity of using these, you know, devastating floods as an example, where we can merge those intact ecosystems with flood protection and start having those cross dialogues, so that when we're preventing an area from development, it's not just the ecological lens, but it's the public safety lens as well. So I think we have an opportunity here to do so. So I think, it just could be strategic time to really push as HRM and other areas are starting to develop more of their flood mitigation strategies and mapping. Well, let's put the two layers together and see where we can actually protect and create these flood resistant or flood resilient, I would say, systems. That's my two thoughts about that.
Yeah. I have a question.
Go ahead, David.
I'd ask Danica, the Advocate Dike, are you working in that area at all? I
was actually there this weekend.
Oh, okay.
So informally, yes. Formally, no. Within that area, and it is a complicated system. but I'm not directly on a project in that area, but I have a lot of personal interest. And it's a beautiful marsh around that area as well.
Yes. I'm just wondering how optimistic you might be that the type of thing you're doing could be done there and help significantly.
Yeah. So that area is similar in terms of vulnerability of the area that's behind. So the work that we do really much involves re-allowing tidal wetlands to come into that particular system. So you're opening up the dike. It would be very challenging in the Advocate area.
Exactly. That's the problem.
But you could, without looking at it in detail, there could be some benefit. But the challenge in that system is that it's more from kind of an overtopping flooding behind rather than kind of like a wave energy dissipation. And in that period, the studies that I have looked at and talked to people, that relocation of some of the infrastructure in that area is going to be ultimately in the longer term. Going to be the solution in that community.
Yeah. I have a friend who lives in that area, and he tells me there's a house there that they actually have a rowboat in the basement, a functional rowboat in the basement.
Yeah, I can see that.
I'm monitoring the chat here, and there's a lot of love and praise to you both, so thank you. We have just about 3 minutes left, so maybe we can do one question. If we have time, maybe another. But I'm just going in order here. So I'm wondering if Elizabeth asked, I wonder if the Nova Scotia Nature Trust or any other conservation groups are making the effort to purchase the land in the backlands for conservation. Do you know, David?
Oh, yes. There's there's a very active backlands coalition. And definitely and Nature Trust has protected I think 2 new properties within the last 2 years there. And I'm aware that there's other stuff going on. So that's definitely occurring. I'm fairly optimistic about most of it ultimately being protected.
Awesome. Thank you, David. And this one's a little bit similar, but Heather is wondering about crown land around East and West Pine Island Pond. There are many wetland vernal ponds and diverse species of plants. And they're concerned about what could potentially be permitted on crown land regarding development. I think, David, that's another question for you.
Well, that part is a little bit different from a lot of the rest of the backlands. It's a wetter area. I just hope they don't develop down there. What can you say? Yeah, I don't know what else to say.
Agreed.
Those are beautiful. They're really beautiful systems down there, and they support a lot of aquatic birds and so on. Yeah, so I hope they won't be developed, but I can't tell you more.
Okay, maybe we can squeeze in one last question because I think it's a good one. Mel asks, is there a key area young people entering the industry should focus on to contribute to the greater overarching goals of wetland conservation? I think both of you might be able to answer that if you want.
I'll defer to Danica.
Okay.
Still in the education system.
Yeah, so I say there's actually lots of opportunities in terms of getting involved within wetland conservation and actually implementing on the ground some of these particular options. I would encourage, there's a real shift now of, rather than focus, narrow specialization, of having capacity to be broader integrative, because tackling these kind of issues requires a multidisciplinary background and multidisciplinary approaches to it. So I wouldn't say there's one key area, but I would say recognizing diversity of experience and diversity of points of view is going to be and the example of the conservation and EMO together, that's typically something that's not done. So I see that as the new frontier, the multidisciplinarity, allowing and broadening horizons. So in your education, having the diversity of courses that you end up taking from conservation and ecosystem to perhaps geography, GIS, geomatics, to have that broad-rounded background.
Yeah, David, we have just a few seconds. Go ahead.
I just thought of something I didn't think of, was aware of, but I didn't think of in terms of these smaller wetlands. There is a provision in the wetland legislation that you can collect, you can protect a collection of smaller wetlands if they're connected. So I guess part of the answer to that, you want to protect some of those things, you need to look at these water courses and map those out and show that they're connected. And then yes, even within the existing system, they could in principle be protected. So that's something to be aware of, I think, where people are concerned about that in specific instances. If they can actually map those out and show how they're connected, they would have a basis to protect them when they might otherwise not.
Great. Thank you so much, both. Wonderful presentations. The discussion was really awesome too. Again, seeing a lot of love and praise in the chat for both of you. Yeah, thank you to the attendees for coming as well. We really appreciate your time and being here and listening to these great presentations. I do want to plug the rest of Wetlands Appreciation Week. Just put the link in the chat earlier. Tomorrow, Transcoastal Adaptations is doing an event at the Converse Marsh where you can meet the marsh. I just put the link in the chat there. Danica let me know that there's still some space, and if you need to carpool from you, that's also an option. So thank you so much. Have a great day and enjoy the rest of Wetlands Appreciation Week.
Thank you too.
Thank you, Jess, Mimi. Thanks to everyone. Bye-bye.
Thanks, everyone. Bye.